I was able to move the nose cone to another location to let it finish curing. And now I'm going to test fit the motor mount here into the body tube. It's really snug there. And it might be due to that little bit of epoxy that got on there. We're going to have to sand that down a little bit. Okay. That middle ring seems like it might be a little tight as well. Okay, but what we're going to do here, once again, is once this is inside, I'm just going to glue in the front pieces first. And so the idea is to have some epoxy up in here that will catch this ring. The problem is that once it gets far enough in there, I don't have enough space to get some epoxy in here. So what I will do actually is start by putting in a heavy ring of epoxy right in front of the fin slots, and then as I push this in, most of that epoxy is going to form around this ring, and then some of it though will still be enough that it'll at least catch some of the middle ring here. Now once the middle ring is in and we go to put the fins in, most of the strength for the middle ring will be done from this side. As we epoxy in the fins, we can also run some epoxy down along onto the edges, both inside and outside of the body tube centering ring here. So this will get most of its epoxy at the same time that we epoxy the fins in. Okay, now something I have done in my own history that I don't want to do again is we need to make sure and tie on the shock cord before we mount this in. So what I'm going to do is first of all sand down the outside ring just a little bit more, and then we'll come back, retest fit that, attach the shock cord, then it'll get stuffed down inside here, and then we should be ready to go to glue this into the body tube. So with a little more sanding, I was able to make this fit properly, and part of the problem was actually the washer that's on the eye bolt here. That was sticking out just a little hair, and I just sanded that down as well. So now everything fits in smoothly all the way up to where it needs to go there. And I'll just check all the way around. Okay, that plywood ring is just a little teeny bit off perpendicular, but it's not going to be anything to worry about. Okay, so before we put that in though, we do need to make sure and tie on the shock cord. So we've got about 5 meters of shock cord here, which is more than adequate. And according to the instructions, we need to tie an eye loop through the eye bolt here. Now, this is also what's called a fisherman's knot, and normally if you're just making a loop, you could do this. You just take the whole thing in your hand, make your loop, and pull the loop through. Okay, and then you've got a loop there. Now the problem is we can't do that here because there's nothing to put the loop through. Okay, now you can do this by actually using the loop as a slip knot. The alternative is you actually just tie a loose overhand knot, right like this, pass that through the eye bolt, and then what you're going to do is follow the knot back. So I'm going to run this along the same direction here, pulling it along. All right, what I'm doing is simply following the webbing all the way back through the knot here until I reach this point. Now the tricky part is getting everything back parallel to each other so you don't have an even bigger knot that you need. If you've ever done any mountain climbing or rope work, that type of thing, this is very similar to tying in to a safety line. I am out of practice doing this. There we go. Okay. So the main thing I was trying to make sure I was doing was keeping all of the webbing flat, so I didn't end up with a twist in here somewhere that would weaken my knot some more. Alright, so now I'm just going to pull on this whole thing. And to make this stronger, I'm going to put a little bit of epoxy on this when I go to epoxy in the motor mount. Okay. The other thing you might want to consider doing is putting a Nomex shot cord protector over this. And you can do that at this point. It just slides over this, or you can do it later. The various manufacturers make them that you can put on after the rocket's been built, and they just slide all the way down. Okay, that's up to you. It doesn't come with the kit. Right. So now what I'm going to do is fold this all up, stick it inside the motor mount, and then we'll be ready to put it in. One other thing before I switch camera views here is my aft ring. I've put 2 small holes in it, and I'm just going to thread some string through that. This is a leftover piece of Kevlar from another project. Doesn't have to be. Just some sturdy string, some twine will work, some nylon cord, whatever. I'm just going to pass this through. This is a whole lot bigger than it needs to be. So this way I can still reuse my string again. Alright, so just a loose loop here. And what this will allow me to do is put this on to help keep the motor mount centered while it's being glued in, but then I can use this to pull the ring back off when I'm ready to put the fins in, and that'll give me access to the interior so that I can put in my internal fin fillets. Right, I've got 5-minute epoxy that I'm now applying to the inside of my body tube, up beyond the fin slots there. Alright, I'll just check and make sure I've got it going all the way around. It looks like I need just a little bit more, so I'm going to make up a little bit more really quick here. Okay, made up another quick batch. Since this is 5-minute epoxy, I'm going to have to work pretty quickly here. And on the other hand, you don't want to skimp up there because that's what's holding everything together. I already put a little bit of epoxy on my knot, and just be careful you don't epoxy your knot to the motor mount. And now we're just going to slide everything in. Okay, just until the motor mount is flush, and that ring should be right on the edge. And we've got a little bit of stuff coming out of there, so I'm going to take some rubbing alcohol and a paper towel. And just clean that right off, especially there where it's coming out of the fin slot. That's definitely not something we want plugged up right now. Take a couple of paper towels here, and this is going to be out of the range of the camera. And I'm just going to stand this straight up. And just let that harden in place. The epoxy is almost cured. It's just got a little bit of give left here, and so I'm taking this opportunity to adjust the motor mount in relation to that middle centering ring so that the ring is right at the very edge of my fin tab slots. Okay, and I'm going to go ahead now and just let that cure the rest of the way. Alright, and remember my aft centering ring, I put some string on there. Now I'm going to use it. And this is going to fit. I'm just barely putting this in. And if you slopped any epoxy, you definitely don't want to put this in it. So I made sure to wipe that off. Okay, and now once more I'm going to go ahead and do just a little adjustment. That epoxy is almost too set. The epoxy on the motor mount has at least partially cured. It's set enough that I don't have to worry about it coming loose here. And now I'm going to get ready to put the fins on. Now these fins, when I bought this kit, the advertisement had said they were pre-tapered, and it turned out they weren't. They came with squared edges, and I've considered just leaving the squared edges in place because I actually thought they looked really cool that way. But I ended up going ahead and tapering them somewhat, and I started this using a router table and a 45-degree angled bit, and I just took the very edge off each side, and then I took some medium grit sandpaper and just rounded all of the edges here along. So it's not a true airfoil, but it is somewhat tapered and rounded, and mainly what it does is it takes the sharp edge off it. That was the one problem with the squared edges here, is those corners are actually pretty sharp. You end up cutting yourself on them. Okay, so however you want to do that, you want to do it before you get ready to mount the fins. It's a lot easier to manipulate the edges here before it's on the rocket. One thing I've not done here yet is we'll need to roughen up right along here. Okay, so this is the fin tab, and so the squared area here is going to be inside the rocket, and we'll have an external fillet that goes roughly right along here. So we're going to want that to be roughed up a little bit, and that you may actually want to wait until you get it in the rocket before you do that. Now you will also want to rough up this edge here. In fact, I would just rough up this whole tab and just right above it, because we will be making internal fillets on the back side of the back side of the body tube, and also to the motor mount here. And so we'll want to have some rough surfaces there for the epoxy to adhere to. And then the other thing, as you noticed here, the fins aren't quite going into the slots, and I thought I had done this already, but this is what happens when you get too many rocket projects going at the same time. Okay, so here what I'm going to do is just take a small flat file, and I'm going to file each one of these just a little bit. Now make sure that you're wearing protection here. So I've got my gloves on, I've got a mask on, and glasses on. And that may just be enough there. Almost. Okay, so I'm going to have to do the same thing to the other 3 slots, and then make sure that we get all the dust out of there once more before we go to start gluing. I've done all my sanding and filing now, and I went ahead and numbered the fins with the slots that I tested them in. Most of the time it doesn't make a whole lot of difference, but this way if there's some minor imperfection or something like that that allowed one fin to go in and not another, I don't have to fool around with it. So this is my number 1 fin and my number 1 slot, and now it will fit right down there. Okay, and I'm going to go ahead and, when I put these in, I'm going to push them forward into that middle centering ring, and then in the back I'll be able to push the aft centering ring all the way up against the fin tabs once we get to that final stage of finishing off the fins and motor mount. Okay, notice I've also roughened up my fin tab and brought the roughness up into just the base of the fin itself where the fillets will go. Now to tack these in, I am going to use gel type super glue or cyanoacrylate. And I'm just going to run a bead of this along the entire edge of the fin tab. Now this by itself is not enough to glue the fin in securely, but this will tack it in and hold it until the epoxy actually gets in there and cures. And this will also allow me to test fit the fin, and if for some reason I get it in crooked, which does happen, or there's some other problem with it, it's a lot easier to remove the fin when it's super glued in there than when it's epoxied. So if I have to remove this fin for whatever reason before the final epoxy job, I can just apply a little acetone to the dried cyanoacrylate and I'll be able to break that free. Now you do want to have a little bit of patience here. Some people like to try and get in and just go tack them all in at once and put the rocket on its end, and I found that sometimes when you do that they slide. So I'm just going to be patient here, and I'm going to let this one dry and then come back and do the other 3. I've moved my rocket to the floor here for easier access both for the video and while I epoxy the fins. The super glue has been hardening for at least an hour. For some of the fins it's been hardening overnight. And now I'm going to use some 15-minute epoxy to add fillets along the edge of the fin tabs, attaching them to the motor mount. And then I'll also do the same thing where the fin tab comes through the body tube here and have a fillet on the inside of the body tube. Now you could use 5-minute epoxy for this. The reason I'm using 15 is to allow it to actually run down, because the other thing this is going to do is reinforce that middle bulkhead, or middle centering ring, excuse me, to strengthen it, since we could not initially put a fillet on that. And also remember that it didn't get a whole lot of epoxy, since most of the forward epoxy was pushed by the forward centering ring. So it's only got a relatively small film of epoxy holding it in place. And so this will reinforce it. You could use 5-minute epoxy if you wanted to here. If you do, I suggest you mix it up in small batches and essentially do one fin tab at a time with it. Okay, so now I'm just going to start ladling this in, and try not to get it above the fin tabs here. other reason to use 15-minute epoxy here is that it'll probably remain workable all the way through, so that if I decide that I just need to put that aft centering ring on because of slopped epoxy here, I can just do it. Alright, so here I'm using some rubbing alcohol on a tissue to remove excess epoxy that got too far back on the motor mount. Okay, and so I'm just going to continue this for the other 3 fins. I'll have to make up more epoxy in the process. As I said, this is going to require quite a bit just because of the size of the fins and the number of surfaces that we're gluing here. So I've got all the epoxy now on the inside fillets, and now I'm going to go ahead and just run a bead of epoxy right above the fin tab line there, and this will be for my aft bulkhead. I'm being a little bit sloppy here, but it'll all end up down in the bottom where it's going to reinforce that centering ring anyway. And then after I've got the aft ring installed and it's had time to cure, then we'll run another fillet on the very aft side of that centering ring, and that will seal everything together. Okay, and I'm also going to get along here. Okay, some epoxy on the motor mount side as well. Okay, and I've removed the string. We no longer need that, and the little holes will get filled in with epoxy. Okay. Alright, so that's now in place, and then I'm going to clean up some of that residual epoxy there with rubbing alcohol, and I'm just going to set this whole thing aside and let it cure for a few hours. My internal fillets are still curing, but it's been a couple of hours now, and so it's at least safe to handle the rocket without anything spilling out of it. And I want to take a look at the section on rail buttons here in the instructions, because you may run into some contradictions like I did. Okay, so in the instructions they indicate drilling a 5/64 inch hole for each rail button. One from about 7 inches from the top of the body tube, and the other at 1.5 inches from the bottom of the body tube. Now, what they describe in here is using number 6 wood screws and spacers. Okay, well, alright, so this is what we've got. This is the rail button. This is the spacer. This is not a number 6 wood screw. This is a number 8 machine screw. Now this will still work, but to do that you're going to have to drill a bigger hole. So I would start with a 5/32 inch, and what that'll do is give you just a little bit smaller hole than the screw is, and this will enable you to actually thread the screw through the hole. It'll still bite in and do that. What I recommend is threading the screw in, then backing it out, and then putting the epoxy on it like they recommend here, and then putting it back in again. And so this would look something like that. Okay. Now what I've done here is I've actually bored that out a little bit more. I put in a 3/16 inch hole because I'm going to mount this using one of these. This is called a T-nut or a weld nut, and unfortunately there are other things called T-nuts and weld nuts that don't look like this. So if you just look up T-nut on an internet search, a lot of times you'll see something like this, but it'll have teeth coming up and it's meant to be embedded into wood. Or a weld nut may just be basically a flat piece of metal with a a threaded hole in it, and it's meant to be welded on to something else. This is too, okay, but this particular one, it's got a threaded shaft here, and then this wide flange on the bottom of it. And what we do with this is put it up inside here. Okay, so like this. Now let's see if I can do this in a coordinated fashion. Alright, now this is a number 6 thread, so it's a 632 thread, and so the spacer would go on top, and then the actual rail button, and I don't have one handy, but then you would stick a number 6 machine screw down through this, preferably one that will fit into the recessed part of the rail button here, although a round-headed one will still work. The advantage to this is twofold. One is that the flange inside here spreads the stress out over a wider distance. Now normally the rail buttons don't encounter a lot of stress, but if you have a wind gust come up really strong at one point or something like that, that can put stress on here, which might tear the threads out. The other nice thing about this is it's nice and flat here on the inside, and if you get the proper length of a screw, you can make it so that the end of the screw never leaves the threaded portion here. So you still get the strength of having a nut on the back side, but nothing will protrude back here, and this will lay relatively flat against the inside of the body tube. And you can even then take a little bit of epoxy and cover what does stick up and smooth this out, which means that you're less likely going to have the parachute or the rest of the recovery system getting hung up on a protruding screw in here. Alright, if you use this method where you just pop the screw in, a little bit of that screw is going to protrude beyond there, and that might catch on your parachute or on a shroud line, maybe even on the shock cord, although that's a little less likely. If you use the wood screws that were originally supposed to come with this, you'd have to do the same thing. You'd want to either take some epoxy and kind of cover that up, or take a file and grind part of that down. I just like this. This is something I learned when I was building my Zephyr, and it seems like most of the Apogee kits come with this as a base for the rail button. And I think it's just a really great idea, and so I've used it whenever possible ever since. Okay, the other modification I made was down here on the aft end. It's also got the bigger hole to accept the T-nut, but I didn't bring it all the way up to 1.5 inches, which would be right here, right next to my aft centering ring. And the reason for that is to make sure I've got enough clearance for the T-nut here, and that it's not running into the centering ring back here, and that it's not either bumping up against or interfering with the fillet that's going to go on the aft end of that ring. And so bring it back just 1/2 inch or so here. Not going to hurt it at all. It's still got lots of room in here to catch on and distribute any tension in there. I've got my camera hanging over the floor again here with my rocket up, and what I'm going to do now is put on my last set of interior fillets. So these are going to go along the edge here of the aft centering ring, and also where that centering ring meets the motor mount. And then we'll also put on the engine retainer on the very aft end of the motor mount here. And my intention here is to actually cover most of this aft centering ring with a thin layer of epoxy, and that will help plug up the 2 little holes I have in here that I used for removing the centering ring. And then that'll also just give a nice smooth finish. And then last, we'll do the motor mount here. So this is where the engine retainer will go on. I'm trying not to get epoxy there. I'm just going to take the motor mount here, squash it down. Okay, a little rubbing alcohol here to clean up any drips that we didn't want up here. And again, I really should be wearing gloves here. I tend to forget. Okay, so now I'm just going to let this settle, and the epoxy will fill in and level out things here. And then we're almost done here. The last thing to do really is to put on the external fin fillets, give it a coat of paint, and then we'll put on the rail buttons as the last thing. The epoxy on the internal fillets and on the aft part of the centering ring has cured overnight, and so now I'm ready to put on the external fillets. And here I'm going to use some 5-minute epoxy, and the trick here is to be patient. What I'm going to do is the facing fillets here, so both fillets are on the same side of the rocket here. And I've got this set so that the rocket remains level. If it's tilted either way, the epoxy may run to the front or the back of the rocket, and this will give you an uneven fillet there. Some people like to have really built up fillets, and if you're going to do that, most people will use a clay type epoxy or a paste type epoxy for that. I recommend going ahead and using the 5-minute epoxy initially, especially if you are going by the instructions and did not put internal fillets in. So if that's the case, these external fillets are going to be the primary point of strength for your fins, and you'll want something stronger than a paste type epoxy. If you want to build up the fillets after that to get that more of a blend with the body tube, do that after the initial fillets. So what I'm going to do now is just place this in between my masked off area here. And I've masked off about 1/2 centimeter on both the fin side and the body tube side. And I'm just going to start out by just Getting a good thorough covering here all the way along the fin length on both sides. And now I'm just going to let that partially cure for a few minutes, and then I'll shape it. Now for the shaping part, I am going to just use my gloved fingers here. And it's something I found, if you normally wear, say, a large glove like I do, if you can, put a medium-sized glove on so it gives you a tighter surface here. And this is just going to give you more control over the fillets. Also make sure that you have some rubbing alcohol handy, because what we're going to do is I'm going to wet my fingers with the rubbing alcohol so that they don't stick to the epoxy as much. And then we'll also need rubbing alcohol on a tissue or a paper towel to clean up some of the edges here. So I've allowed the epoxy to just sit there for about 2 or 3 minutes. And now I've wet my glove with some rubbing alcohol. And now I'm just going to use this to smooth my fillet here. Okay, and in between, I'm wiping off my glove to get rid of the excess epoxy. And then I'm going to spray again here. Re-wet my glove with some more rubbing alcohol. And now I'm taking a tissue that's been moistened with rubbing alcohol here, and I'm going to use this to wipe off the excess around the edge. There's actually some dripping along the back here. I'm going to just kind of run it into the next fin for the moment. And again, I'm just going to use my alcohol soaked tissue here to get rid of any excess. If you need to, you can always build these up. It's a lot more work to take them down. And now I'm going to let these set for another minute or so, and after that I will remove the tape, and this will allow the still somewhat plastic epoxy to then blend into the fins here just under the influence of gravity. Just gently peel this off. Can't quite get a fingernail under there. Okay, now I'm just going to make sure this is level again. And even though this is 5-minute epoxy, I'm going to let this sit for at least 20 minutes before I rotate it and go to the next set of fins. While I'm waiting for my fin fillets to finish curing, I'm going to jump ahead here and talk a little bit about recovery systems. Although this kit does come with a shock cord, it does not come with a parachute. And part of the reasoning behind that is that a lot of Rocketeers, especially when we get into high power, will just have an assortment of parachutes that they'll swap out between their different rockets. Generally because high power rockets take longer to set up on the pad and such, there's always time to switch things out. Now on the MadCow site, they recommend a 50-inch nylon parachute for this particular rocket. And I'm going to show you here a little project I tried. This is actually the canopy from a large Gulf-style umbrella. The umbrella frame had broken, but I went ahead and salvaged the canopy here. And after a little bit of online chatting with some other experienced high-power people, it turns out that somewhere between the time when I first got into rocketry as a kid in the 70s and now, there was a lot of conversion of parachutes going on. And then as the internet became more developed and people started publishing plans for cutting out the gores of more complex parachutes and such, they moved to doing that. But this is actually a good way to recycle a broken umbrella. It's not ripstop, but it's still a good strong nylon. And what I've done here is use some Kevlar thread to sew this shroud line on. And this is just 1/16 inch braided nylon. You do want to use braided rather than the twisted. This costs just a little bit more, but it's much less likely to come undone. And what I've done here is made basically a hairpin bend shape here, and then sewn that on using a zigzag stitch. I'm using Kevlar here both because of its strength and because it's fire retardant. The parachute itself is not, but common thread that's cotton or polycotton is going to be more susceptible to possible flame damage or heat damage here. And so I've used that, and then something I found while sewing with the Kevlar is it doesn't hold back stitches or knots very well. And so I used a little bit of super glue to act as a fray check here, and at my beginning and end points I went ahead and tacked that on with a little bit of thin super glue to keep the stitches from coming undone. Okay, in reading a couple of rocketry books, the consensus seems to be that the shroud line should be 1 to 1.5 times the diameter of the parachute. So this parachute, it's an octagonal canopy here, and so from side to side is 52 inches. So this is just slightly larger than what the recommended chute is. But the good part is this hardly cost me anything. Maybe less than $1 for the amount of cordage and Kevlar thread that I've used. And like I said, this was essentially free because I already had the broken umbrella. Okay, just a thought. Otherwise, you'll want to go ahead and buy a parachute of the appropriate size to go into this rocket. One of the nice things about this, since it's a 4-inch diameter rocket, you can put a pretty big parachute in this and still have lots of room to spare. I've let my fillets cure overnight, and they've come out really nice and smooth here. And depending on your personal aesthetic, you could build these up more and kind of blend them into the body tube better. I actually like them just the way they are. And so, except for the painting and a few last-minute attachments, this rocket is essentially done. You can see here I've got the motor mount retainer here masked off in preparation for painting. And up on the forward end here, I have my other hole for the rail button, and then this is an 1/8 inch hole up here. This is a venting hole to keep the body tube from becoming pressurized as it gains altitude, which could possibly at least cause the nose cone to be ejected prematurely. Okay, so kind of one last thing here. I discussed earlier different ways that these rail buttons could be put on, and so this is kind of what comes in the kit. What comes in the kit is actually a round head machine screw here of a number 8 variety. This is a number 6 flathead screw, And this is a T-nut, okay, also called a weld nut. And its diameter here is about the same size as a number 8 machine screw. And so what I've done down here is drilled a hole that's a 3/16 inch, which is just big enough for this to go through. So my rail button will come up here from underneath, and my big fingers won't quite squish into there, so what I'm going to do is just thread this on and then pull. There we go. Alright, so this spreads out any tension on the rail buttons, which normally don't experience a whole lot anyway. Alright, but my spacer will slide over the T-nut, and then the actual rail button fits on top. And these rail buttons have two sides. One side has a flat surface, the other side is recessed. And so I'm using the recessed side here, since I have a flathead screw. And it just fits right down in there. Okay. Now, if I was doing this for real, I would epoxy in the T-nut first and then put this in, and either use some epoxy on the threads or a little bit of thread lock to hold this in place. Now, some people like to keep this a little bit loose so that the rail button can turn freely as it slides up the rail. I've also done it where it's been cinched down, and at least as of yet I've never had any problems with it. But if you're looking for altitude records and you want to get as much out of this as you can, yeah, keeping a little spin on there might be good. Now, to do that, you do have to lock that screw in place, though, because you don't want to just have this loose and have no other means of holding on to it, or that rail button may actually come off. The only other thing I've done in the meantime was to the nose cone here. I went ahead and added some more epoxy down inside to make sure that my threaded rod is good and anchored in place. So I've got a total of about 100 grams of epoxy in my nose. And I've gone through and simulated all of this in RockSim. And this gives me a margin of stability of at least 2 with all of the rocket motors that I plan on flying on this. So I shouldn't have to add any additional nose weight, just the things I've built into it to allow opening of the nose cone provided sufficient mass that way. Okay. Really the only other thing to do here, and I won't do it until after I've painted it, is to attach the shock cord to the nose, and that will be via the U-bolt that we put on earlier. And then to add the parachute that we saw a little bit earlier here, in this case made out of a broken umbrella. So that's all I've got for this. Maybe later I'll get pictures of the finished product up, but usually that takes me so long I like to get the videos up ahead of time. So I hope this was a fun and challenging build for you, and have a good flight.